Friends, myself Dattatreya Jadhav. I am from sgm College Karad. In previous video, we are learn about integration by partial fractions. First type, denominator contains non-repeated linear factors. So, in this video, we are discussing about integration by partial fraction in which denominator contains repeated linear factors. Here is the second type. Denominator contains repeated linear factors. Means that factor is repeated, linear factor is repeated. That is, our p of x divided by q of x, that is fraction is of the type p of x divided by linear equation is what? Ax plus b bracket raised to r, means ax plus b is repeated here r times, means ax plus b into x plus b into x plus b, so on, that r times, means that factor is repeated. So its corresponding partial fraction is in the form of a divided by, consider that fraction one time, repeated one time, that is, it is one time only ax plus b, plus b divided by, consider that factor repeated two times, that is ax plus b square, plus c divided by, consider that factor repeated three times, ax plus b bracket raised to 3 plus so on, that it's r times that constant something k divided by ax plus b bracket raised to r. For example, here is the example 1 upon x plus 1 bracket 2. The corresponding partial fraction of this is, look at here, x plus 1 bracket cube is nothing but 1 upon x plus 1 into x plus 1 into x plus 1, means x plus 1 is repeated 3 times here. So using 3 constants, here it is repeated r times using r constants here. So a divided by, consider it is only 1, plus b divided by, consider it is repeated twice, so x plus 1 square, plus c divided by, it is repeated 3 times, x plus 1 cube. It's a corresponding partial fraction of the given fraction 1 upon x plus 1 bracket cube. And take another example, 2x plus 1 divided by x plus 1 bracket square into x minus 1, which is equal to, here x plus 1 repeated 2 times, so 2 constants are there, and here is again x minus 1, so third constant is there. A divided by x plus 1, its corresponding partial fraction is a divided by x plus 1 plus b divided by x plus 1, it repeats 2 times, plus c divided by x minus 1. Since this factor is non-repeated type, so c divided by x minus 1. We saw some examples on this type. Here first example is, here first example is, evaluate integration of 3x minus 2 divided by x plus 1 bracket square into x plus 3, x plus 1 bracket square into x plus 3 dx. Clearly it is example on integration, so denote the integration by I. So starting with, let I is equal to integration of 3x minus 2 divided by x plus 1 bracket square into x plus 3 dx. Here degree of numerator is 1 and degree of denominator is 3. So it is a proper type of integration, and in denominator there is a linear factors, x plus 3 is a linear factor, x plus 1 is a linear factor, and x plus 1 repeated twice. So example is on when denominator contains repeated linear factors and x plus 3 is not repeated. So we saw this integration by partial fraction. Consider only fraction. Fraction is what? 3x minus 2 divided by x plus 1 square into x plus 3, which is equal to, here how many factors are there? 3 factors are there. X plus 1 into x plus 1 into x plus 3. So use how many constants? 3 constants. A divided by x plus 1 plus b divided by, since this is repeated, so repeat again, x plus 1, but here is square, plus c divided by x plus 3. It's our equation number first. Now taking LCM of RHS, here LCM is x plus 1 bracket square into x plus 3. So 3x minus 2 divided by x plus 1 bracket square into x plus 3 is equal to, multiply this a by x plus 1 into x plus 3 plus this b by x plus 3 and this c by x plus 1 bracket square, cancelling the denominators. Therefore 3x minus 2 is equal to x plus 1 into x plus 3 into a plus x plus 3 into b plus x plus 1 bracket square into c. It's our equation number second, and here equation second is true for all values of x, for all real numbers, but we put values of x as proper values to get a, b, c. Put x is equal to find, check here common factors are x plus 1 and x plus 1. Here is x plus 1, x plus 1. Make that terms are 0. When x plus 1 is 0, common factor in these two are x plus 1. X plus 1 is equal to 0. It means that put x is equal to minus 1. Put x is equal to minus 1. This implies 3 into minus 1. Minus 3 minus 2 is equal to, here minus 3 plus 3 get cancelled. Minus 1 plus 1 get cancelled. It's 0. 0 into any number is 0 plus minus 1 plus 3. It's 2b and minus 1 plus 1 again 0 plus 0. I don't write there 0. Therefore, this implies minus 5, minus 3 minus 2 minus 5 is equal to 2b. Value of b is minus 5 divided by 2. Here is the value of b, minus 5 divided by 2. Now put x is equal to, take another common factor. Here common factor is x plus 3 in these two terms. So make that common factor is 0. X plus 3 is equal to 0. It means that x is equal to minus 3. Put x is equal to minus 3. When we put x is equal to minus 3, 3 into minus 3, minus 9 minus 2, it's minus 11 is equal to minus 3 plus 3 0, that term is 0, minus 3 plus 3, that term is also 0. Don't write minus 3 plus 2. Minus 3 plus 2 is minus 2 bracket square into c. This implies minus 11 is equal to 4c. This implies c is equal to minus 11 divided by 4. Here is the value of c, minus 11 divided by 4. Now there is no common factor. There is no common factor remaining. So for finding the value of a, put any value of x. Put x is equal to, for easily calculation I can put here 0. Therefore 3 into 0 is 0, 0 minus 2 is minus 2 is equal to 0 plus 1 is 1 into 0 plus 3 is 3 into a plus 0 plus 3 is 3 into b plus 0 plus 1 is 1, 1 square is 1 into c, it's c. Therefore, minus 2 is equal to 3a plus 3b minus plus c. To find value of a, I can write this as 3a is equal to minus 2 minus 3b minus c, and put here values of b and c. Minus 2 minus 3 into value of b is minus 5 by 2 minus value of c is minus 11 by 4. After simplification we get 3a is equal to minus 2 minus minus becomes plus 15 divided by 2 minus minus becomes plus 11 divided by 4, making denominator same. Here 4 means we multiplied minus 2 by 4, minus 2 by into 4 is minus 8 plus multiplying by 2 it's 30 plus 11 minus plus 30 minus 8 plus 22 plus 11 plus 33 divided by 4. 3a is equal to, so 3 11s are 33. Value of a is 11 divided by 4. So equation first becomes, therefore equation first becomes 3x minus 2 divided by x plus 1 bracket square into x plus 3 is equal to a divided by, it's 11 divided by 4 divided by x plus 1 plus b divided by, b is minus 5 by 2 divided by x plus 1 square plus c divided by, c is minus 11 by 4 divided by x plus 3. Now we have to find integration of 3x minus 2 divided by x plus 1 square into x plus 3. Replace that term by this. So our integration becomes I is equal to 11 divided by 4 into, I can write this as 11 divided by 4 into x plus 1 plus minus becomes minus 5 divided by 2 into x plus 1 square plus minus minus 11 divided by 4 into x plus 3 dx. Since numerator of denominator comes in denominator, inside the integration there is subtraction, so separate integration sign. Inside the integration there are constants, take constants outside the integration sign. So integration becomes 11 upon 4 into integration of 1 upon x plus 1 minus dx minus 5 divided by 2 into integration of 1 upon x plus 1 square dx minus 11 upon 4 into integration of 1 upon x plus 3 dx. Look at here, 11 upon 4 is constant as it is. Integration of 1 upon x plus 1 is log of mod of x plus 1 minus 5 by 2 is constant. Here we use integration of 1 upon x square. Integration of 1 upon x square is minus 1 upon x. So it's minus 1 upon x, that is x plus 1. Into divide by coefficient of x, that is 1, don't write there, forget about it. Okay, so or you can solve this integration by writing integration of x plus 1 bracket raised to minus 2, use x raised to n. So second next is minus 11 divided by 4 into log of mod of x plus 3 plus constant of integration c. Here 11 by 4 is common here, so taking common 11 by 4 into log of mod of x plus 1 minus log of mod of x plus 3 minus minus becomes its plus 5 divided by 2 into x plus 1 plus constant of integration c. I can write here final answer is I is equal to 11 divided by 4 into using laws of logarithms, log m minus log m upon n. So log of mod of x plus 1 divided by x plus 3. Here minus minus becomes plus, plus 5 by 2 into x plus 1 as it is plus constant of integration c. Here is the answer of the given question. 11 divided by 4 into log of mod of x plus 1 divided by x plus 3 plus 5 divided by 2 into x plus 1 plus constant of integration c. Now moving to our next example. Next example is evaluate integration of 1 upon 2 sin x plus evaluate integration of 1 upon 2 sin x plus sin 2x dx. Sin 2x dx. First denote the given integration by I. So starting with let I is equal to integration of 1 upon 2 sin x plus sin 2x dx. Here we see that there is a term of sin 2x using formula of sin 2 theta. We know that sin 2 theta is 2 sin theta cos theta. So integration becomes I is equal to integration of 1 upon 2 sin x plus 2 sin x into cos x dx, which is equal to, after simplification, taking 2 sin x common from denominator, we write this as integration of 1 upon 2 sin x into 1 plus cos x dx. Integration of 1 upon 2 sin x into 1 plus cos x dx. We are adjusting the term of sin x here, multiplied numerator and denominator by sin x. So sin x into 1 is sin x divided by 2 into sin x into sin x is sin square x into 1 plus cos x dx. Why we multiplied by sin x? To get derivative of cos x. Sin square x can be written as it's sin x divided by 2 into sin square x can be written as 1 minus cos square x into 1 plus cos x, that term as it is dx. Integration is integration of sin x divided by 2 into 1 minus cos square x into 1 plus cos x. Now use the formula a square minus b square. 1 minus cos square x can be written as 1 square minus cos square x, and factors of this is 1 minus cos x into 1 plus cos x into 1 plus cos x is here dx. Now we put here cos x is equal to t, therefore derivative of cos x is minus sin x dx is equal to dt. We find here sin x dx is minus dt. Here is the term sin x dx. I can write instead of sin x dx it's minus dt. So integration becomes I is equal to integration of minus dt divided by 2 into 1 minus cos x is what, t, 1 minus t into 1 plus t into 1 plus t, means we write this as cancelling the minus sign or taking minus sign inside this bracket, 2 into t minus 1, minus becomes plus, plus becomes minus, into its 1 plus t square, 1 plus t into 1 plus t, 1 plus t square. Now here denominator contains repeated and non-repeated linear factors. So we write I is equal to 1 upon 2 into integration of 1 upon 1 plus t square into t minus 1 dt. How many factors are there in denominator? There are 3 linear factors, so we solve these by partial fraction. It's our equation number first, partial fraction. Consider the fraction. Consider the fraction. Which is the fraction here? 1 upon 1 plus t square into t minus 1, which is equal to. Since it is repeated twice, there are two constants, a divided by 1 plus t. Consider it is only 1 plus b divided by, consider it repeats twice, 1 plus t square, 1 plus t bracket square, plus for that non-repeated linear factor I can write c divided by t minus 1. It's our equation number second. Making denominator same, that is taking LCM on RHS, we get LCM is 1 plus t square into t minus 1. Means we have to multiply a by 1 plus t into t minus 1 plus b by t minus 1 and c by 1 plus t square, 1 plus t bracket square, sorry, 1 plus t bracket square into c. Cancelling the denominator on both the sides, we write this as 1 is equal to 1 plus t into t minus 1 into a plus t minus 1 into b plus 1 plus t square into c. It's equation number third. And remember, equation third is true for all values of t. But we put proper values of t here, put to get a, b, c. Here is the common factor in these two terms, t minus 1. Put t minus 1 is 0. That is when t minus 1 is equal to 0, the answer is t is equal to 1. So put t is equal to 1 in equation third. We write equation third, put t is equal to 1. 1 is equal to t is equal to 1, 1 plus 1, 2. Look at here, 1 minus 1 is 0, 0 into a is 0, 1 minus 1 0, 0 into b is 0, 1 plus 1, that is 2 square into c. This implies 1 is equal to 2c, 4c, 2 square is 4, c is equal to 1 upon 4. Here we get the value of c, 1 upon 4. And one more common factor is here. Common term is what? 1 plus t in these two terms. There is common 1 plus t. When that term is 0, 1 plus t is equal to 0. When t is equal to minus 1. So put t is equal to minus 1. When we put t is equal to minus 1, LHS is 1, 1 is equal to 1 minus 1, 0, so this term is 0. Here 1 minus 1, that term is also 0. 0 into any number 0. Here what becomes minus 1 minus 1. I can write directly minus 1 minus 2 into b. This implies b is equal to minus 1 upon 2. Here we find the values of c and b. But what about a? Put any value of t there, put any value of t there, I can put that value is 0 for easy calculations. So 1 is equal to, in equation 3, 1 is equal to 1 plus 0 is 1, 1 plus 0 is 1 into 1, 0 minus 1 is minus 1 into a plus 0 minus 1 is minus 1 into b is minus b plus 1 minus 0 is 1, 1 square is 1, 1 square into c. After simplification, it's minus a minus b plus c. 1 is equal to minus a minus b plus c. But we have to find the value of a. So taking a on LHS, a is equal to minus b plus c minus 1. Put the values of b and c here. Put the values of b and c is here. Minus b is 1 minus 1 upon 2 plus c is 1 upon 4 minus 1. After simplification, it's 1 minus minus becomes plus 1 upon 2 plus 1 upon 4 minus 1, making denominator same. It's 4 multiplied by which term? 2 plus 1 minus 4. 2 plus 1 is 3. 3 minus 4 is minus 1 divided by 4. Its value of a. Means here we get the values of a, b and c. I clean in this side here. Therefore, equation second becomes, what happened with equation second? 1 upon 1 plus t bracket square into t minus 1, which is equal to a divided by, a is minus 1 upon 4 divided by 1 plus t plus b divided by, b is what here? Minus 1 upon 2 minus 1 upon 2 divided by 1 plus t bracket square plus c divided by, what is c? C is here 1 by 4 divided by t minus 1. On simplification, I can write this as minus 1 upon 4 into 1 plus t minus 1 upon 2 into 1 plus t square plus 1 upon 4 into t minus 1. Since denominator of numerator is always comes in denominator, so it is the corresponding partial fraction of 1 upon 1 plus t square into t minus 1. Therefore, I can put that value in equation number first. Therefore, equation number first becomes I is equal to 1 upon 2 into integration of, it's minus 1 upon 4 into 1 plus t minus 1 upon 2 into 1 plus t square plus 1 upon 4 into t minus 1 dt. Inside the integration there is addition and subtraction. So separate integration sign and taking constants outside the integration. 1 upon 2 into curly bracket. Here minus 1 upon 4 is constant outside the integration. Integration of 1 upon 1 plus t dt. Minus 1 upon 2 is constant. Integration of 1 upon 1 plus t square is here dt. Plus 1 upon 4 is constant. 1 upon 4 is constant. Integration of which function is here? 1 upon t minus 1 dt. Curly bracket complete. To evaluate, here is substitution is here. Put cos x is equal to t. Don't forget about that substitution. 1 upon 2 as it is into. To evaluate first integration, it's log of mod of 1 plus t minus 1 upon 2 into integration of it's 1 upon x square. Integration of 1 upon x square is minus 1 upon x. So integration of 1 upon 1 plus t bracket square is minus 1 upon 1 plus t divided by coefficient of t, that is 1. Don't divide by 1. Write as a term that as it is. Plus 1 upon 4 into log of mod of t minus 1 and plus constant of integration is c. Therefore, next step is I is equal to, after simplification we write this as I is equal to 1 upon 2 into minus 1 upon 4 into log of mod of 1 plus t. Minus minus becomes plus 1 upon 2 into 1 plus t plus 1 upon 4 into log of mod of t minus 1 plus c. Look at here, in these two terms we take 1 by 4 common. So 1 upon 2 into, taking 1 by 4 common, inside the bracket it's log of t minus 1, that term, minus log of 1 plus t, that is t plus 1, plus 1 upon 2 into 1 plus t as it is, plus constant of integration c, curly bracket complete, which is equal to, multiplying by 1 upon 2, it's 1 upon 8, 1 upon 8 into log of mod log m minus log n, it's log m upon n, log of t mod of t minus 1 divided by t plus 1 plus 1 upon 2 into 1 upon 2, it's 1 upon 4 into 1 plus t or t plus 1 as it is, plus constant of integration c. But here answer is in variable t because of our substitution. So what is t? T is cos x. So answer is 1 upon 8 into log of mod of cos x minus 1 divided by cos x plus 1 plus 1 upon 4 into cos x plus 1 plus constant of integration c. Here is the final answer of the given integration. It's 1 upon 8 into log of mod of cos x minus 1 divided by cos x plus 1 plus 1 upon 4 into cos x plus 1 plus constant of integration c. So here is the second type of partial fraction, when denominator contains repeated linear factors, that is 1 plus t square, 1 plus t bracket square. 1 plus t bracket square is 1 plus t into 1 plus t, that is 1 plus t repeat twice. So this is the examples on partial fraction of a denominator contains repeated linear factors. I hope you understand today's examples in this video. Thank you for watching the video.